Okay, fellows out there, welcome to my lecture 14 of module 1 in the video series Introduction to Data Structures in C. So today we'll be looking at 5 demo codes. Okay, and what I want you to do is basically listen to this lecture, go back and try to mimic these codes without having any reference or help. Okay, so that will give you a fair amount of idea about to what extent you will be able to apply the knowledge that you have gained from my previous videos into actual practice. So let's get started. The first code is very simple. I want you to basically write a code to print this particular string USA India with a space in between. Okay, so sit back and let's look at the code here properly. Let's get into the details of the code. Okay, and in your leisure time please sit back and try to replicate whatever we have learned so far. Okay, so that's how we print USA in India and India, USA India, using a C program. So first I have my two standard header files being declared in the preprocessive directives. Then I have my main function, okay, return type int main, open and close parenthesis. Mind you, any function, this is mandatory for any function to be a valid function. The input argument, even though if it doesn't take anything, the open and close brackets are mandatory. Okay, and then I have the scope of the main function, the curly braces, as you remember. Okay, and then let me just declare and initialize the character array. Okay, so I have taken a character array. Name of the array is nation, and the length of the array permissible is 20. Okay, so that's how a character array is being defined and being initialized. Okay, and let me initialize that to USA and India. Make sure that it is a string, so you have basically used the double inverted commas to uh, demarcate the string. Okay, so that's the string USA space India. So having done that, the next line of code basically prints out the string for you. Remember, printf is a formatted way of outputting data. Okay, so I have to give the format specifier. Again, the format specifier is given in double inverted commas percentage s. S stands for string, and I print out the character array in which the information is stored. And the name of the array, as you know, is nation, so I print out the information stored in the character array nation. Okay, so fairly simple. And the output of the code when you run this would be USA India. Okay, so go through these lines one by one, make sure that you have understood all the concepts. Okay, and try to replicate. Okay, so let's go to the next line of code. Okay, in this code I want to write a C code basically which tells me what is the memory space allotted by your compiler for a int, double and character data type. Okay, so you might have different results than what I would have got. Okay, because that depends wholly on the target that you have set. Okay, so in my case it is my system and my OS which is the target in which I'm planning to run the code. You might have a different OS, you might use a different compiler altogether. Okay, a different C compiler. Okay, so let's look into the code. So that's the code. Okay, again I have my preprocessive directives, and then I have my main function. And since I want to know what is the memory allotted to store the information of int, double and character, it's not required, but I have declared three data types. Okay, so int I, character C, double D. You could have very well given them as char. Okay, int, so here I have given char. Okay, so I is int and D is double. Okay, so let's go one by one. Okay, having declared these three variables, let me first print out what is the memory space that is being reserved for an integer. Okay, so I have given out, I print out a message, integer type uses percentage D type of memory, bytes of memory. Okay, so this percentage D instead of this percentage d, the value given out by this particular function will be printed. Okay, so that will be printed out here. Okay, so whatever is the output of this function will be printed in place of percentage d. Okay, and here I've used the size of built-in function size of function. Okay, so what is the size of I? Okay, so I have declared I and I have defined it. Okay, and what is the space that the compiler has reserved to store information for this particular variable? Okay, so that will give me the value. Similarly, for a float, I use percentage d bytes of memory. You could have used percentage p as well. Since you are printing out memory size, percentage p would have been better, but still, okay, percentage d works as well. Okay, so here instead of using c, as I said, you can as well as use the data type of the variable. No need to write the name of the variable. You can write any variable but of this particular data type. So that is permissible, it's valid. Okay, so size of, for a size of function, the input can be a data type, it need not be a variable. Okay, so for character data type, what is the size of memory that my compiler allocates? Okay, so whatever this function returns, again a integer value will be printed instead of percentage d out there. Okay, similarly for a float, which is for a double, which is d, I could have written double out there, but here I have preferred to write d. Okay, just to make sure or highlight the fact that both data type and variable names are permissible for size of operator. So whatever this returns is printed in place of percentage d. Okay, and that's the code, and the output that I get in my compiler is 4. So 4 bytes of memories are allocated for integers, 1 byte for character, okay, and 8 bytes for double. Okay, so that is the memory allotment of my system. Okay, so let's look into another program. This program basically wants you to convert degree centigrade to Fahrenheit. Okay, and the formula for degree centigrade is Fahrenheit is equal to 1.8 into degree centigrade plus 32. So this is the formula to convert centigrade to Fahrenheit. Okay, so I need to basically implement this equation, and there is one input variable which is degree centigrade and one output variable which is Fahrenheit. Okay, so in my main function, again I have the preprocessive directives. Okay, and then I have my main function. So in my main function, basically I use two variables, one to store the input and the other one to basically store the output of the equation after calculating the output. So I have these two variable defined. Okay, and then I print out a message saying that please enter the temperature in centigrade. So when you run this program, the first output that you see on your console will be this message. So the compiler will ask you, will print out a message asking you to type in the required value for the degree centigrade. Okay, and then I use this scanf, again formatted way of input. Okay, so the syntax, as you know, is scanf formatted way. So percentage f, because c is a floating point variable. Okay, and as I said, don't forget the ampersand, the address of operator. Okay, so take the input from the keyboard in a floating point way, store it in the memory allocation or memory allotted for c. Okay, so address of c. So this basically scans your keyboard, takes the information, converts it to a floating point number and stores it in the memory allocation in the address of C or memory allocated for C. So that is what happens in this piece of code, this line. Okay, so having got the value of C, now I can calculate what is the value of F. Okay, I can calculate what is the value of F. Okay, so I use my formula F is equal to 1.8 into C. This bracket out here would not be mandatory because I know that multiplication has higher precedence than addition, but it is always a good practice. Okay, don't hesitate to use brackets wherever you feel like. It doesn't add anything extra to the compilation time or the execution time, nor does it add anything more to your code size. Okay, so wherever you feel brackets are necessary, please do go ahead and use them. Okay, so this makes it very legible for the uh, person who is reading the code. So he basically comes to know it is 1.8 into c, and then I need to add 32. Okay, so that's what happens. So the value of c is being multiplied by 1.8, so two floating point numbers will give me a float, plus 32 integer plus float is also a float, and that will get stored into a floating point variable f. Okay, then I print out the value of f that I have just calculated. So for a temperature in Fahrenheit is equal to percentage f comma f. Okay, so whatever is stored in this f variable will get printed out here. Okay, so that is what happens. Fine, hope you have understood this part of the this program. Okay, so let's go into another program. This we have already seen in my previous lecture when we had discussed about the if else if statement. Okay, so the uh, if else if statements, okay, that is the staggered if statements or control statement. Okay, but we'll have another look into this particular code, and we'll see into the details of it. Okay, what is given out here is you have been asked to calculate the roots of a second order quadratic equation. Okay, and I know that the roots of the second order quadratic equation, since the order is 2, there will be two roots x1 and x2, and this is the formula for calculating the roots. Okay, so first I calculate the discriminant part or the delta. Okay, minus b square minus 4ac under root. Okay, and depending on whether this is greater than 0, equal to 0 or negative, I basically have three conditions. Okay, so that's the code. Okay, so in the initial part I basically have declared variables to store the value of a, b and c. Then I have two variables to store the values of the output, those are the roots, and I have an intermediate variable to store the value of delta or the discriminant value. Okay, so then I ask the user to basically print I give a message to the user to enter the values of a, b and c using the printf command. Okay, and then I scan the variables or the values of these variables using the scanf command into address of a, address of b and address of c. So having done that, I calculate the value of delta, that is b square minus 4ac. Okay, so depending on whether this takes a 0, a positive or a negative value, I have three conditions. So three blocks of code needs to be executed. So I use the control statement. Okay, and obviously you know which one. Okay, the if statement. So the if statement, if the delta is smaller than 0, that is if it is negative, I directly print out there are no real roots. Okay, and there is no equation has no answers. It can have an imaginary root, but I kept the code simple. Okay, so I print out this command saying that the equation has no roots, and that's the end of it. So the next execution comes out of the control statement, loop of the control statement. So it comes out directly out here and returns the enter basically returns 0, and that's the end of the code. Okay, suppose if the value of delta is not negative, okay, then I go and check for the next condition. So this is if. Okay, so next what does it do? It basically sees if delta is equal to 0. If delta is equal to 0, then this piece of code runs. Okay, so then what I do, I have if delta is equal to 0, then the roots are minus b by 2a. Okay, and both of them are same. Okay, so I calculate the value of x1, and x2 will basically have the same value of x1. So I print out x1 is equal to x2 is equal to x1. Okay, so percentage f. So this gets printed out here. Okay, so that's what happens. Okay, so this line gets executed. If delta is 0, then this part of the code gets executed. Okay, that's it. Fine. Now if both these conditions are false, then the last condition should be true, so you can use an else, or you can directly say that okay, I'll directly do it. Okay, so you can put it in the else part. In fact, there should be an else out here. Okay, there should be else. Okay, so if this is not true, then the else part, the next condition will obviously be true. Okay, so here I calculate two real values of the roots. Okay, minus b square root of I use these equations out given out here to calculate the value of x1 and x2 and then print them out. Okay, and that would be the end of the code. Okay, hope you have got the logic behind how to solve a second order differential quadratic equation. Okay, fine. So in this part we'll look into basically operator precedence. Okay, we have talked about operator precedence regarding which operator runs first and which at a later stage, and we have talked about the left to right or order of precedence. So we'll just check them out. So having given four variables and their respective values, say a, b, c and d with values 20, 10, 15 and 5 respectively, I would like you basically to determine what are the outputs that you get for these four equations for the value of a, b, c and d. Okay, so let's look into the coding part. So obviously I have in my main function, I have declared these four variables and then initialized them to their respective values. Okay, and then I have a variable to be, you could have done this in one single line, you could have put a comma there and you could have done that, but I want to keep it very distinct. Okay, so that's it's a personal choice. Okay, so then I have basically I have declared another variable for the output, which is e, which I will be printing out after evaluating each of these equations. Okay, so the first equation is bracket a plus b into c divided by d. Okay, so how does it gets evaluated? First the brackets gets evaluated. The bracket has the highest precedence, so a will get added to b. So a is 20 plus 10, that becomes 30, and then basically it becomes 30 into 5, 30 into 15 divided by 5. Okay, so that gives me basically 90. Okay, so fine, that is what you get as the output of this code. Okay, and in the next line I have a plus b into c divided by d. Okay, so what happens out here? Okay, here there should have been another bracket because that is what is being implemented. Okay, so put another bracket. That is how you get 90 out there. Okay, fine. So look at this piece of code. What happens? It is a plus b into c divided by d. So as you know, inside the bracket, it looks into this bracket, and inside this it takes into account the operator precedence. So a plus b doesn't occur first, but you basically do b into c, so that becomes 150. Okay, and 150 plus 20, which is the value of a, so that is 170 divided by 5, so that gives me 34. Okay, so next, if we had calculated a plus b into bracket c divided by d. Okay, so that becomes 10 plus the value of this should have been 20. Okay, 20 plus 10 into 15 divided by 5. So 15 divided by 5 gets evaluated first, that is 3. Okay, then it becomes 20 plus 10 into 3, so 30. This becomes 30. 30 plus 20 is 50. That is how you get 50 out there. Okay, so hope you are following it. So this gets evaluated, this becomes 3. So then multiplication has higher precedence than addition, so this gets 10 into 3 becomes 30, and 30 plus 20 becomes 50. Okay, so that is how you get 50 out there. Okay, so let's look into the last condition. Okay, it is a plus b into C divided by D. Okay, so that's what is being evaluated. Okay, so how does that get evaluated? Okay, so initially I know that the multiplication has the highest precedence, so B into C will get evaluated first. Okay, so that becomes 150. Okay, and then the division has higher precedence than addition, so 150 divided by 5, so that basically becomes 30, and 30 plus 20 becomes 50. So that is how you get 50 out there. Okay, so 50 gets printed out there. Okay, and that is how you get this as your output. Okay, that 90, 34, 50, and 60. So takeaway from this lecture is, depending on how you put your brackets, the compiler basically gives you a very different kind of results for these equations. The only difference in all this equation is the way in which I used my brackets. Here I put it out here, then here I put it like that, and here I shifted the bracket here, and here there are no brackets at all. Okay, so be careful when you are using equations with different operators, and be very clear about the operator precedence. If you are not sure about what you are doing, make sure that you use brackets very uh, uh, tactfully, so that you get exactly what you are expecting out of the equation. Fine. So that was all about operator precedence. Okay, so fine. So thank you for being with me for this lecture. Okay, and hope to see you back in my lecture number 15. Thank you.